This podcast is for CNT140. We're going to discuss Chapter 6 on work area outlets. This one we're going to look at different types of mounting for work area outlet, surface, flush mount, those kinds of things. We'll also talk about the outlets themselves, the outlet jacks themselves, and how to terminate them. And then we'll talk a little bit about fiber optic and fiber optic outlets that we would have, configurations that we would have, and then a little bit about documenting and labeling of all these outlets. All right, so let's dig in. First thing we want to remember is our 568C standard in C1 indicates that a minimum of 2 permanent links shall be provided for each work area. If I take a look at our 568C standard, 568C1, I'm going to go down to the area that actually talks about our horizontal cabling system. Here a little bit further. Horizontal cabling system. Remember, horizontal cabling from our patch panel in the closet, horizontal cabling out to the outlet at the user area that the user is going to plug into. Our standard actually calls for a minimum of 2 permanent links shall be provided for each area. That's kind of the old standby of 1 outlet for computer, 1 outlet for phone. If we do IP phone, we can take and combine basically the IP phone and the computer into 1 outlet, but the standard wants to make sure that there is 2 connections there for typical office location. The other part that it mentions, if we look down at the bottom of this page, is the recognized cabling that we can use for this. 100 ohm unshielded twisted pair kind of thing, multi-mode single mode fiber. Those are the recognized medias that I can use for those 2 permanent links that should be installed at each work area. So the first part of the chapter, when they introduce this to us, they remind us that our standard calls for 2 outlets at each work area and what the requirements are for those, what type of media. Here I'm updating it a little bit more than the book and kind of looking at our current standard and what it calls for, but this is what our current standard calls for those media outlets. The book also reminds us that the work area outlet, also called telecommunications outlet or connector, book refers to it as station outlet. Most of the time you're going to hear me refer to it as the outlet jack or the work area outlet kind of thing, just so you're kind of recognizing that. Reminding us of where this is in the grand scheme of things. If we look at our data closet, here's our rack of equipment in our data closet. We have, patch panel, network switch. We're using patch cables between them. Horizontal cabling goes from the patch panel out above the ceiling, down the hall, down the wall, to an outlet box. Well, we're now talking about this part of the structure. Okay, if you think we've talked cabling already, we talked about pulling cabling, we even pulled cabling in the lab room. The next logical step is this piece here. Next week, or kind of looking one more week down the road, we're going to look at the patch panel end over here. So we're starting to look at our first major component in our system, the work area outlet. This is the part of the system we're talking about in this chapter, Chapter 6. And it includes the outlet jack, the faceplate, the box. That's all necessary here for the work area. For the think of somebody sitting at their desk, their computer on the desk, the box on the wall behind it that they're plugging the patch cable into. We're talking about this area of the system, the work area outlet. Typically what I'm going to find is a actual outlet jack that snaps into a faceplate, and this whole unit screws on top of a box that would be on the wall, possibly in the wall. This is the part of the system we're talking about now, this right here. We're looking at basically all 3 of those pieces here in the course of this chapter. That's where we're going. Well, the 2 major types of outlet jack mounting that we run into is flush mount and surface mount. Flush mount is the box is mounted in the wall. The outlet box is kind of in the wall, if you will. So the faceplate and the outlet jacks are flush with the wall surface. The other style, surface mount, the box itself is on top of the wall, mounted on the surface of the wall. So the box, faceplate, and outlet jack are sitting on top of the wall surface. We're going to talk about these two different ways of mounting, kind of the pros and the cons, and where you would typically find them. Just to kind of remind you, or I should say kind of get your brain organized here. Here is examples of flush mount. We see almost all of our electrical outlets that we deal with are flush mount. The box and all that stuff is in the wall, and the only thing out for us to see is the actual plug that we plug into. We can do the same thing with the data jack. The box and everything is in the wall, and our faceplate screws on top of the wall. We plug our patch cable into that. Meanwhile, surface mount Here's just an example of an electrical outlet that was mounted kind of after the fact, after the building was built, maybe many years after. The box is on the surface of the wall. We can do the same thing with our data too. We can actually mount a little box on the surface of the wall. So there's our flush mount, flush with the wall, surface mount, it's on the surface of the wall. Alright, so let's start looking at flush mount. We'll go through kind of all the pieces and parts of dealing with flush mount. So if I'm going to deal with a flush mount, the jack faceplate is flush or even with the wall. This is typical and familiar with commercial wiring in a commercial building. This is very common. Outlet jack extends into the wall and mounts to a box or some sort of mounting ring underneath. So we now want to talk, if I'm going to do flush mount, outlet box or mounting ring, there's two different methods. I could do flush mount. The outlet box method is just that. An outlet box is anchored to studs in the wall, probably as the building is being built, and the cabling is run down through the wall and comes out through the outlet box. Or I use a mounting ring. Here's a mounting ring. An actual ring is anchored to the stud or put in place after the fact, and our wiring comes down the wall and just out through the ring. The outlet box method, this is very similar to what you would have for electrical wiring, electrical outlets. So this is very common. Most people recognize that and can deal with that, but it, for the most part, does need to be done when the building is being built. We'll get to some more of those details in a minute. Here is a couple different outlet box styles that you might use for the outlet box mounting. Meanwhile, the mounting ring method that you see here, the proper name is actually low voltage mounting bracket or low voltage mounting ring, because it is suitable for anything that is low voltage, things like data, voice, or cable TV. This is not acceptable for electricity. There's nothing to contain that if there is a electrical short. You know, a box actually contains it if there's an electrical short. That's why you put your electrical outlets in a box like that. Low voltage mounting ring, that's not acceptable for electrical wiring, but for our data, voice, and cable TV, that is acceptable. So that's why they call it a low voltage mounting ring. Well, I can do my data in either one of these, a box or a voltage ring, low voltage mounting ring. The outlet box method are similar, as we said, to the electrical boxes. They come in single gang and double gang sizes. That basically that's the terminology they use for if I have one outlet there or two outlets there. And here I have examples of a single gang box, double gang box, or triple gang box. These are pretty common for electrical boxes, so I could do the same thing for data. And here's a couple more examples of single, double, triple, that sort of thing. That's just the sizing of it. For mounting rings, I put them here as well. Mounting rings come in single gang, double gang, or triple gang. And that just gives you more capability for more outlets or more data jacks, data outlets, if you will, in this case. Again, outlet boxes are similar as electrical boxes, and they're going to be placed at roughly the same height above the floor as electrical boxes. In some areas, there might be a code that actually says that it has to be mounted at the same height. Here, just giving you an example, typical electrical box outlet is at this height, usually in the 12 to 16 inches above the floor. Switch box, I don't remember that one's much. I think it's about 48, 50 inches, somewhere in that ballpark. But if I'm going to mount data outlets and outlet boxes, I'm probably going to mount them at the same height as my electrical outlets. That's just kind of a standard that you would do. If I'm going to use an outlet box method, I can do it pre-wire or post-wire. I can install my data jacks into these outlet boxes, pre-wire, post-wire. Well, pre-wire is when the building is being built, when the building is being constructed, being roughed in, I actually put the electrical, those boxes on the wall, on the studs, and then come back later, pull the cable to it, etc., etc. Or I can do it post-wire. Happens after the building has been constructed, maybe even years later. This may or may not be able to be done depending on the construction of the building. Pre-wire, I can put the boxes there on the studs as it's being built, run the cables to it and drywall over it, all that good stuff. Post-wire, I come back maybe years later, install the boxes in the wall, but I usually can only do this if you have a hollow wall, drywall kind of thing. I usually cannot do post-wire if I'm dealing with concrete wall, concrete block wall, brick wall, that kind of thing. So pre-wire, I'm going to mount all my mounting rings or boxes as the building's being built. So here's an example of an outlet box that would be anchored into a wooden stud, and actually showing you how to do that. Same thing with a mounting ring, screw it on or nail it in as the building is being built. And I might even run my wires down and kind of feed them through and have them ready. If I'm dealing with a commercial building with metal studs, same thing, screw them to the metal stud here. Screw your mounting rings to the studs here, and place it all. Even possibly run the wires down and curl them up in the box before the drywall is put on. Then they come back and put the drywall in. You pull the wire out, terminate the outlets, and screw it into the wall box. There is possibility of damage to the wires during this, but that's a very common way of doing flush mount. So again, during the rough-in stage, I'll put the boxes up, outlet boxes up. I'll run the wire to the outlet boxes, pull some extra cable, coil it up, put it in the box. After the drywalls come in and put the drywall up on the wall, I'll come back and re-terminate the outlets, or I should say terminate the outlets. Another way that you could actually do this is run conduit to the outlet boxes. I pause there for a second. Another way to do pre-wire is I put the boxes on the wall studs, that sort of thing, and run conduit to the outlet boxes, put a string in there. After they do all the drywall, then I use the string and pull my wires through and then terminate them. In some commercial buildings, you might actually do that. Meanwhile, if I'm going to do post-wire with outlet boxes, again, after the building has been constructed, maybe many years later, I can actually put boxes in the wall and do flush mount if I have hollow wall or drywall construction. I usually cannot do it if I have concrete block, masonry block, brick kind of walls. I cannot feed wiring down through those. The hollow wall, I usually can cut a hole in into the wall cavity and get some wires down to it and feed it down through. So if I'm going to do that, mount the hollow walls, I actually cut a hole in the wall, slide the box in, anchor in place kind of thing. I can do that, but I need some special boxes to do that, outlet boxes to do that. And I actually have remodeler boxes that are designed to, I cut an opening in the wall, slide the box in, and when I tighten these screws, these little ears pop up and anchor the box to the wall. It actually does work like that. And they have mounting rings that do the same thing. I cut the opening, slide the ring through, and when I tighten it up, these little ears pop up and anchor the ring into place. I also have mounting rings that these little tabs here, after I feed the bracket through, I bend the tabs over like this, feed it through, I bend the tabs over, and that anchors to the wall, and then I can screw my faceplate onto that. So there is mechanisms and boxes to do this after the fact. I just have to have that hollow wall to be able to do that. So for post wire, if I'm going to do flush mount, I need to examine the wall for any pipes, cabling, that sort of thing. Drill maybe a small hole, take a peek in there, make sure there is nothing, measure my outlet box, mark the wall, cut the opening for the box, carefully slide the box in place or the ring in place, feed the wiring down through the wall, through the frame or box, or the ring or the box, and then terminate my cabling onto the outlets and then screw the faceplate onto the ring or box. So it can be done, but I do need that hollow wall that I have access to be able to do the flush mount. Alright, so with my next method, we'll come back in the next podcast and start talking about surface mounting. So there's our flush mount. Just kind of remind you, we're looking at this type of installation here, this guy right here. That's what we're looking at with our flush mount. And typically I can do that when the building's being built, or after the fact. If I have hollow walls, I can usually get to that and install a flush mount. Alright, when we come back, we'll start talking surface mount.